find the length of the cardioid, r equal 1 minus cosine theta. Let's go ahead and get a sketch first. So I'm going to draw this with theta and r, and I have cosine, which is reflected and shifted up 1. So I'll put this here, and we know that cosine of 0 is 1 and then shifted up 1 and then reflected, so it's going to be right here. Our period is 2 pi, so we can make this one 2 pi, so this will be pi and this will be pi over 2. So we're going to go to this middle and then maximum and then middle and then minimum. So here is our graph. Now let's go ahead and graph that in our polar world. So we look at this at 0, we are at 0, and then pi over 2 we are at 1, and at pi we're out at 2, and then 3 pi halves we're back at 1, and then back to 0. So we have this cardioid that looks like that, and we are looking for that length. If I trace this out, how long is that? And we derived the formula in the concept video, so this is the formula for arc length. So as we look at this, the length we're going to integrate from, now since we started here at 0 and we traced this out and it's symmetric to the other half, we could do a double and do 0 to pi if we wanted to. And it's going to be the square root of r squared. Here is r, so if we square that, that's 1 minus 2 cosine theta plus cosine squared theta, and then plus dr d theta squared. Dr d theta, as we look here and differentiate this, will be sine theta, and then we need that squared. So plus sine squared theta d theta. Now in looking at that, here's my favorite trig identity. So that equals 1. We can combine it with that one. So it looks like we have 2 times the integral from 0 to pi of the square root of 2 minus 2 cosine theta d theta. Now we're actually going to use a trig identity we've used for integration. We're going to kind of use it in the other direction. So it's going to be 2 integral 0 to pi square root of, I can factor a 2 out here, and what that leaves me, I'm leaving some space because here it leaves me a 1 minus cosine theta. And if I had a 1/2 out in front of that, then that would be my double angle identity, the one side. But if I put a 1/2 on there, I've got to compensate for that by putting another 2. So let's see what we've got. We have here this part right here can be replaced with an angle. This would have been 2 theta, but it's theta, so we can replace this with theta over 2. And then here I have 2 times 2, which is 4, so I can square root the 4, and it'll come out as a 2, and we'll let it join that one that's out there. So we're going to have 4, and then we have the integral from 0 to pi of replacing this with, this is sine of theta over 2 squared, and we have the square root d theta. So I just used that double angle identity. We started here with this sine squared theta over 2 and got 1/2 1 minus cosine of theta. And now we can go ahead and have this squared and square root cancel here, and we're going to have 4, and this will be cosine theta over 2, so we're going to need a negative 2. I guess I'll put it right here. And then we need to evaluate that from 0 to pi. So as we look at that, we can combine the 4 and the negative 2, and we're going to have negative 8 cosine of pi over 2. Well, cosine of pi over 2 is 0. And then we'll have negative, and minus minus is a plus, and then we will have cosine of 0, which is 1. So it looks like we get for our length 8.